my name is Javier Cubo. I'm from University of Malaga, Spain. I'm one of the partners participating in the SeaClouds project that had been invited to present the demonstration in the interoperability demonstration day at the conference of utility cloud computing in 2014 in London. And we want, of course, to thank the organization to invite the project to give the possibility to present our results during our first year. Basically, the main objectives of the SeaClouds European project is to manage cloud applications at runtime. So what we are going to see during the live demo is how we can design the application, how we can discover the best cloud providers to distribute the different modules that you have in your application. For example, in your cloud application, you can have a database or a PHP web server module and so on. And these different modules can have quality of service requirement or properties that are appropriate for every module. So sometimes you need to deploy, or it's better deploy one of these modules in one cloud provider and the other module in another different cloud provider. But it's not only this, it's also what SeaClouds is working on, is giving the possibility to manage this at runtime. So if some violation happens, we are going to migrate one of the modules where the violation happens according to service level agreement, according to metrics or sensor that we are defining. So we are solving also the problem to migrate the different modules. And this is what we are going to see during this live demonstration. I'm going to present a live demonstration of the SeaClouds European project. It's a project that from the October 2013 was initialized, and we are in the first year of the project. So basically what we are going to show here is a proof of concept of the SeaClouds dashboard as a result of the early prototype of the first year of the project with the main functionalities that we have. Basically, we have an application designer component, a discoverer and planner component, a deployer component, a monitor component, and a service level agreement service component. All these components are constituting the SeaClouds platform itself. Well, with SeaClouds platform, what we pretend to do is give the users, the software developers, the cloud application users, the opportunity to achieve agility after deployment with the cloud application. That means that we are going to provide a platform where they can design their cloud applications and they can manage the application at runtime. Also, they can move the different modules of the application and migrate to the different cloud providers, solving the interoperability problems that this provoke. Also, we are monitoring all the activities, and we are incorporating a service level agreement engine to manage at runtime the agreements between the users, the application providers, and also the application providers with the cloud suppliers. So basically, we can not only generate this SeaClouds platform like a wall, but also you as user could use every component of the SeaClouds platform independently, because we are thinking about you, for example, can design your application or only need to deploy your application. So you are going to use the deployer or the monitor or the designer component. So let's play with the dashboard of SeaClouds. Initially, we start with the application designer module, where we can design our cloud application. This is a PHP module of your cloud application, we can add different other modules, like for example a database, where we describe this is a database with different technological requirements, like for example MySQL, non-functional requirements, for example Silver, dynamic location, different policies that we can determine, like follow the sun, quality of service like response time, and we select the provider infrastructure. Currently, in this first year, we are doing the deployment in IaaS level. We have to address the PaaS level, that is one of the main objectives of the SeaClouds project, in the next steps. So we add a new module here, and we connect both modules. With this, we have our use cases using two modules, basically for this live demo that we are going to do. After we design our application, we continue with our next component, is the Discoverer and Planner. This component basically takes a user input where you have not only the specification of your application, where we are using Tosca. Tosca is an Oasis standard that many people is using now, but also we have the information related to the cloud offerings, and we also are using Tosca specification to define the cloud offerings, taking the information from the APIs from Cloud Harmony that we are using currently. So here, what we can do is select our input. Remember, this is a proof of concept, so all the components are not automatically connected. So this is for the next step, where we can take here is our Tosca YAML application model. Basically, you can see the two modules of the application, the database with the different requirements, capabilities, the constraints, like for example the CPU cores, the memory, the local storage, and so on, and also the web server related to the PHP module, also with the requirements, with the region, CPU cores, memory, and so on. When we press this button, Process Application Model, what we are going to do is find the best provider for our cloud application. Basically, in this demo, we are providing that the Neuro database, Neuro is our use cases. In fact, it's one of our partners in the project. And this Neuro database is going to be deployed in HP cloud provider. And the web server PHP module is going to be deployed in Amazon Web Service. So once we have this output from the planner, this is called a deployable application model. Basically, now we are generating a Tosca YAML. If we go, the next step is the deployer. What we are taking here as input is a CAN YAML. These two Oasis standards are very related. SeaClouds itself is a member of Oasis and is working also with one of our partners in the project, CloudSoft, in both standards. And currently, this gap is because we need to take now, for the next steps, more time to extend our engine, our deployer engine, to accept or to support Tosca YAML, because currently it's supporting CAN YAML. So basically, we select our CAN YAML file, and here you have the information of our Neuro case study. It's also a deployable application model, but with using the format of CAN YAML, not the Tosca YAML. This will be for the next step. And here you can see the connection of the database and also different sensors that we are going to consider during the management of our application, because SeaClouds is not only deploying the application, SeaClouds is also controlling the application at runtime. So we are going to monitor in the application using the different sensors that the application provider is interested to check. This is all the CAN YAML. And when we deploy, you can see here the application deployed successfully, and here the application is starting. Okay, I'm sure that you already know when you are doing real deployment in the cloud providers, this takes time, sometimes 2 minutes, other times 8 minutes, depending on traffic and so on. So what we have been doing here is preload a new case study in our 2 different cloud providers, where you can see here the Apache web server and also the database deployed already in HP. But anyway, if we go the instance that we have in Amazon, here we have an instance running in HP before this live demo. And now, if we update here directly, we should see that it is starting a new instance in HP. Okay, you can see here. The good thing is that in HP, this time, the instance is already running, only 1 minute. But Amazon used to take more time. Okay? So if we continue with the demonstration, once we have our application deployed, we should go to monitor the application at runtime. So what these components do exactly is that we can have this live monitor, and we can select different sensors, different metrics, where you have the 2 entities that we have deployed, the Apache web server and also the Neuro database. Okay, so let's search for some of the sensors that we are going to monitor. This one, for example, that correspond to the response time of the PSP module. Also, we can have some corresponding to the database, like for example, the ping database, the per second queries from MySQL, the connection time, and so on. Also, we can have the runtime, or select directly using the different models that we have, like the requests per second, the last requests per seconds to the PSP modules. So here you can see all the sensors we are adding, and we are monitoring the application. Then, after this, what we are going to do in SeaClouds is checking that everything is working well according to the quality of service requirements that we have defined at the beginning, and the service level agreement also is the next component that we have. What we can do basically is generate different templates with the different agreements between the user, the application provider, or the application provider and the cloud supplier. We add the agreements, and this consists basically that at runtime we are going to check the violations that we can have related to our agreement, our quality of service, our quality of business. Here you can see the agreement. The agreement basically is considering the sensor of the average runtime, and the action that should be executed is that we are checking as constraint that the neuron minute average runtime is less than 1.5 seconds, and if this happens, we are going to detect some violations here. And with this, we can finalize the demonstration. So thank you for your attention, and I hope that you enjoy checking the SeaClouds functionalities and watching everything about this live demo. Thank you.